Okay, so today we are going to be practicing calculating frequency and wavelength. So here's our first problem. An ocean wave has a wavelength of approximately 25 meters and the velocity is 5 meters per second. What is the frequency of the waves? Use the Dilthau method to solve the problem. So the first letter in the Dilthau stands for draw. So we are going to draw our wave. Normally we label our wave or whatever our drawing is. And so our ocean wave has a wavelength of 25 meters. So we're going to label the wavelength. It's very difficult to label the velocity, but you could draw an arrow and say velocity is equal to 5 meters per second. All right, L stands for list. So we're going to list our variables. So our wavelength is 25 meters. We know that from reading the problem. And the velocity of our wave is 5 meters per second. And it wants us to calculate the frequency. So frequency is our unknown variable. All right, now F. F in Dilthau stands for formula. So we want to know which formula are we going to be using. So if we look at our triangle, we're solving for F. So I can kind of cover the F with my finger and see that that leaves me with the V for velocity over lambda for wavelength. So that means that I'm going to be using this formula. F is equal to velocity over wavelength. So now I simply plug my variables in. So I plug in for velocity, my 5 meters per second, over my wavelength, which is 25 meters. All right, so move this up and give me a little more room. So now I'm going to do some division, right? So I'm going to divide 5 by 25. So if I'm doing the math, I should come out to 0.2. And now I have to figure out my units. So let's change the color of our pen really quickly. So for my units, I can see that I have this S underneath that M right here. So I'm going to take this S and it's going to actually end up down on the bottom, right? Because it's got this division symbol. And my 2 meters are going to cross cancel, which is going to leave me with a per second. And as you know from our lectures, a per second is equivalent to a hertz, right? Which means that instead of writing per second, I can just simply write the unit as hertz. So this is my answer, 0.2 hertz. Now we check and make sure, does that make sense? Hertz is what we use to measure frequency, and that is what we are solving for. So yes, that is a good example of checking your work at the end and making sure that the units you ended up with actually make sense for the value that you're solving for.